Hi guys, in the list comprehension part 2 video, we had discussed about tables, right? How to create table. So we did create table using for loop and also using list comprehension. See, list comprehension and this for loop we used, we created table and we also looked at slicing part. Now, what we will do is, this is the table that we have, right? We have this table. We will try to transpose this table. So columns will become rows and rows will become columns. See here what happens if I have to pick up any one cell from this table. It has got lot of cells, right? So if I have to take out one, assuming I want to take this 9, this 9. What I will do, what command I have to do? I say table row, this 9. Row is what? It always starts from 0. So row number 1. And then in the next bracket, I will talk about column. So 9 is what? 0, 1, 2. If I write 2 here, I'm getting 9. Likewise, assuming I want to take this 54 here, this 54. Okay. So what I will write? Table 54 count 0, 1, 2, 3, 4. Okay, I will write 4 here. And there are 10 columns. So this is basically starts from 0. So the last will be 9. I will write 8. 8. So what I'm getting? 54 I'm getting. So this is how I can access each and every cell from this table. So to write list comprehension, what I will do is, when I am trying to transpose in my variable, whichever variable I'm collecting this, I will make sure that this I is my row. So what I will do is I will increase my row, this I, whereas my j will be static for one particular loop. So if I write j here, let us let us make sure that j is J is not changing, I is changing, right? So how I can go about this? I will say for I in range. Now I is, see, let us write dynamic variable, right? So this is what it is, right? I should go starting from 0 to till this point. I will not count. What I will do is I will say what is the length of tables. Always it is taken in terms of rows. So it will give me, it is starting from 2 and 10. It will give me 9. I will go from 0 to 8. That is how range works. Right? Very good. Now this is my inner loop and my outer loop will be, look, now I am talking about column, that is J. I'm talking about column. So there are 10 columns, right? So what I will do, for J in range, what I will say, I have to take this length. I can say length table 0. See, when I say table 0, what happens? It gives the entire thing. So I'm taking the length of this. So what is the length of this? 10. Very good. I will go from 0 to 9, right? That is how range works. We know that. So let me go down. Okay. Let me remove this. So I have written this. Now let us see syntactically. So now let me repeat what I'm doing. I'm saying this is my outer loop, this is my inner loop. I'm saying it will go from 0 to 9 and this will go 0 to 8. See, j's value is what? J's value is 0 at this point in time. Okay. Now, i's value is what? Let me write here. I's value would be 0 and J's value is good, 0. So what will happen now? I's value is 0, so it is taking 0. J is 0. What it will take? It will take 2. Next time, this I is becoming what? 1. And j still remains 0. So 3. Again, I will become 2 and j will remain 0. So it is just see going like this. Once this loop is over, when 0, 1, 2, 3, 4, 5, 6, 7, 8, this would be over, right? I will exit, I will go here in outer loop. Now then I would become j will become 1. So what will happen? Again this I is becoming 0. So now sorry 1. So now what happens? Sorry, this is 0 only. I'm confused. I is 0 only. So now here again 0 and this remains 1, 0, 1. Then this becomes 1, 1, 1, then 2, 1, 3, 1, so on. So just I'm going like this. This looks that it is perfectly fine. Let us create this. Okay. I will say table T. That means transposed. Error. Name T. This T. Why I'm writing T here? I should write table. The T doesn't exist. Okay. So the table got transposed. See, 2, 3, 4, 5, blah, blah, blah has come here and this has come here. So this is what is called transposition. But let me tell you, there is no need to work so hard. Okay. There are things available and we should use. So there is a library called NumPy. So I'm importing that library and I am giving an alias name as NP because I don't want to write NumPy. Having imported that, let me import that. All I have to do is I say np t and then I say table underscore t. Oh, what happened? Okay. No. np transpose and I will pass table t. Okay, that is pandas command dot t. So see, this transposition has happened. It is ridiculously simple. There is no need to write such big program, such a huge coding, etc., and break our head to do this. You import this library and write np transpose and pass this table, and it will transpose. And if you want to save it, well, you can save it. Save in maybe you can say table two. Now table two is basically this is not list, mind you. This is not list. This is numpy array. But you want to say, no, I want to convert into list. That can also be done. Okay. So that is how simple it is, right? Now let us see another thing after this transposition stuff. I want to flatten this table, this table, the table, this table which was originally there with us. I want to flatten means it is double dimensional list. I want to convert this double dimensional list into single dimensional list. What I will do? Very simple. Again, you have libraries available. You can use appropriate thing to do this. But how I can write list comprehension to flatten, that is what we are going to discuss. So, see here I go. I will say for I in table. Okay, so what it is getting record by it is we take row by row. Then I will say for so I can also write I'm taking one row. Okay, and then I will say for R in row. And if I do this and if write R here, it has completely flattened your table. So what is happening over here is, let me explain. When I write row in table, okay, this particular entire row will come. Now row contains row. Then I am saying for R in row, this entire row one by one cell will be extracted, and then that R is my expression. So how many parts are there in this list comprehension? I have this piece and then this piece. Now which is outer loop and which is inner loop? Well, this is my outer loop and this is my inner loop. And this is my expression. That means this is what is going to get written. And then I will say table F, that is flat. Okay, what happened? I have not written equal to sign. Okay, now table F is my flattened table. Flattening means single dimensional list. Okay, so this is all about flattening, and you would be required to flatten the table or list quite often when you are using machine learning algorithms, which would necessitate one column coming out of such table. So you'll convert this and use it. Okay. Now let us see another stuff. Okay. We can also see, since we are discussing how to go about in for loop, outer loop, inner loop, what it is. So let me write that. I will say table F1 is equal to empty, and then I will say for row, okay, for row in table, then for R in row, and then I say table F1 dot append, and I say R. Now what happened? Table F1, see, it got flattened. So what we are doing here is to understand how this list comprehension works in various scenarios. We are writing list comprehension and we are also writing for loop. See, over here, the steps are very simple to follow. This is happening, this is outer, then this, and then this, right? And here you will have to wrap your head around how it really works. Here, this is the first piece, then this is the second piece. Okay, so once it has read one record, it will read all the cells of that record and keep passing to this expression. So accumulation is happening over here, this expression. So once it has picked up all cells from one particular row, now outer loop will get activated. It will pick up second row and all the units of second row. So it will go till it continues, and then at the end of the day you will have your output ready. So we have flattened the table using list comprehension as well as for loop like this. Okay, good. Now last we will see this stuff. Assuming that I have two lists, something like this. I have student, students. So I will write a student name. Okay, I will say Meera, Mohan, and Michael. These are three students. Now subjects. Assuming that there is physics, chemistry, and computer science, and maybe I write English. And then that is what. Now, what is the requirement over here? See, all these students have appeared in all these exams. I want to create a table where it will say Meera physics, Meera chemistry, Meera computer science, Meera English, Mohan physics, Mohan chemistry, so on and so forth. And The same thing for Michael as well. This is technically called Cartesian. Okay, we are creating Cartesian product out of these two records. So how we will go about it? It's very simple. What we will do? We will say that for S in students, okay, then I will say for, oh, okay, S is 2 for is 2 in students, for sub in subjects. So what is happening? Just see. And then what exactly you are accumulating? I will say this is 2 comma subject, and then put this outer bracket. That's it. And then put in a variable. I will say Cartesian, something like that. I mean, you can give any name. Okay. What is the problem? Students. I have not activated. Okay. So that's the problems. You know, we write this, the whole thing, and we don't activate it. We don't run it. So what happens? What is visible to us is not visible to computer, and that is precisely why it keeps giving error. Okay. Okay. No problem. So what happened? Meera physics, Meera chemistry, Meera computer science, Meera English, Mohan physics, Mohan chemistry, Mohan computer science, Mohan English. Then Michael's all subjects. Now why you would need this? Of course you will need it practically. What happens if you have data like this? Because now maybe this particular thing will be used to tabulate marks, right? And anything for that matter. So you have some raw data like this and you have created this table, right? Now suppose if you don't want tuple, then it's very simple. What you will do? I will not overwrite. I will say Cartesian 1 and go here. I will say, look, I will have a list. See, this is okay. That got already created. Cartesian 1. See here, it is double dimension. This is also double dimensional list. This is also double dimensional list. Here, inner units are tuple and here it is list. Okay. Now, why so much of difference between tuple and list? See, try to understand this. If I write tuple 1, 2, the problem is I cannot modify tuple. I cannot say that 1 should become 10. It will tell tuple object does not support item assignment. It doesn't. It is immutable object. So let me write that. Immutable object, tuple. However, if so I'm not able to do that, right? That you have seen. Now come to a list. Suppose I have a list B like this, 1, 2. Now I want to change first cell's value, right? Then I will say 100. It allows. Now if I see B, the value got changed. But in tuple, you cannot change. And that's a fundamental difference. Okay. So if you are getting tuple like this, and if you want to modify these cells, then probably you will have to convert them into lists. What probably you will have to. Tuple will not allow you to change. Okay. So that is how it works. I think I will wrap it up here. I will come up with more and more videos on list comprehension. There are many things to discuss. But for now, thank you very much for watching, and I will see you soon in the next video, most probably list comprehension part 4.